So for the second video of this three-part series, I'm going to be talking about reduced row echelon form. Now in that, you learn what it is by the process that I go through in this video, and it's just very basic, simple operations that row operations that need to be done on an existing matrix to convert it into a reduced row form. So I'm going to perform all those row operations on the already existing matrix that we made in the last video, that was A equal to this matrix. Okay, so for reduced row form, my first element of the pivot of my first row should be 1. So how I'm gonna the first row operation that I'm gonna do is I'm gonna multiply the first row by 1 by 3. So how you do that is you put A, uh, first bracket, then you select the first row, comma, colon, bracket is equals to comma 1 by 3 into A, comma 1 comma bracket 1 comma colon. Now what I've done by writing this is I've selected all the elements of the first row and I've equaled them to be 1 by 3 times of what they already are. So executing this wait, something happened. Yeah, okay. Executing this command would give us the first row multiplied by 1 by 3, that is 3 by 1 by 3, 1 by 1 by 1 by 1 into 1 by 3, 1 by 3, which is this, and all the other values. Now for the next part, I need all the elements below 1 to be 0. That is how a reduced row form works. So to make this 0, what I'll do is I'll subtract the whole first row from the second row. So how you do that is I'll select the whole second row, doing this. Now equals to, it will be, this row is equal to the same row, which is this, minus of the whole of the first row. Okay, so when you do this, the whole the this the when you do this, the first row is subtracted from the second row, whereas, so this means 1 minus 1, which will give you 0, 2 minus 0.333, which should give you 1.6667. Alright, so now I need to make this 4 into 0. I'll do the same operation, but this time I'll just put in 3 instead of 2 here. So instead of, also I multiply the first row by 4 when I subtract it. So the third row is equals to the third row minus of 4 times the first row. There you have it, 1, all the elements below 1, 0. Now for the next part, what I'll do is okay, so what this is, now I need to make this into 1. Okay, so what this is 5 by 3. So to make 5 by 3 equal to 1, I'll multiply the whole second row by 3 by 5. Now how you do that is you put A equals to, you select the second row, then you put the second row is equals to 3 divided by 5 into the second row again. There you have it. Now this element is 1, and now because this is 1, and then I need to make the element below 1 to be 0 again. Now to make this 0, this is again 5 by 3. So I'll add minus 5 by 3 times of the second row to the third row. So again you do A of the third row is equals to A, selecting the third row again, minus of 5 by 3 times 5 divided by 3 into the third row, into the second row. So what? Oh, okay, that's an error, and that's a typo, so that gave an error. I'll type it again. Equal to a minus 5 by 3 into a of the second row. There you have it. Now the whole of the last row is 0. That's actually convenient for us because in a row reduced form, any zero rows, any null rows, they have to be at the bottom of the whole matrix. Now the last thing that I have to do is uh, every element above and below the pivot has to be 0. All the elements above and below the pivot has to be 0. For here, for my pivot, the pivot of the first row is 1, so all the elements below it are 0. The pivot for the second row is 1, so the element below it is 0, but the element above it has to be 0 too. So to do that, what I'll do is I'll add minus 1 by 3 times of the second row into the third row. Yeah, okay, so how you do that is you select the whole first row. Doing that, then you put equal to a equals to, select the first row again, and you minus 1 by 3 times 1 divided by 3 times the second row. Have I read that correct? Yeah. Now there you have it. This is our reduced row echelon form. The pivot is 1 for the first row, and it has 0 above and below it. The pivot is again 1 for the second row, and the elements above it and below it are 0, and the last row is 0. So this is a row reduced form. Right. MATLAB also has this inbuilt command for you to directly get the reduced row form for the matrix. What we did was we manually did it by going through the tedious and lengthy process of doing row operations. But then if you really want to calculate it in just one go, what you can do is you use the command ref, and then in brackets you put in the matrix. So if I want to create to get the row reduced form of matrix A as output, what I will do is I put in ref bracket, first bracket A, second bracket close. When you do this, you get this matrix. Now if you go back 20 seconds, maybe 20-30 seconds, you'll see that this matrix is the exact same as the matrix that we got after we performed all the row operations. So this is how we verify that the matrix we got back then was actually the row reduced matrix.